Welcome to Math on Ice. December 2014 integral equations. There are two questions, one question from part B and one question from part C. The first question, let y is a function from closed 0 to open infinity to r be twice continuously differentiable function. So this is a hint given in the problem satisfying the integral equation, and we need to find the solution, right? So we can solve the problem by the method of resolvent kernel, but when you solve you will not find any options true. You will get an answer which is other than the options. So the hint given here is twice continuously differentiable. So we are going to solve the problem by Leibnitz rule. So basically the Leibnitz rule is when you need to differentiate an integral phi of x to psi of x limit, and you have f of x comma t into dt. So this is equal to integral phi of x to psi of x dou by dou x of f of x comma t plus d by dx of your upper limit into f of x comma upper limit, and then minus d by dx of your lower limit into f of x comma your lower limit. This is what your Leibniz rule is. Now we are going to differentiate using this one. So integral, that is, I am going to take the differentiation of this integral equation. Y of x is equal to x cube by 6 minus integral 0 to x minus s into y of s ds. So y dash of x is equal to 3x squared by 6 minus integral 0 to x. When I take the differentiation with respect to x, I'll have this as y of s ds. This part will become 1, right? S is a constant here, so s will become 0. Differentiation of x will give you 1. And then applying the up, so you have negative outside. Applying the upper limit, this one, when you differentiate x with respect to x, we get 1. And also f of x comma psi of x, right? So when you apply x minus x, wherever s is present, you have to put x. So x minus x will become eventually 0. So this is going to become 0 and this is plus 0 minus your lower is already 0. When you take the differentiation also, you will get 0. So y dash of x is equal to x squared by 2 minus integral 0 to x y of s into ds. Now we take again differentiation. This is equal to 2x by 2 minus, when you take the integration limit, I mean, like when you take the partial differentiation here, inside the integral it is independent of x. It is only with a term of s. So we get this part to be 0. Dou by dou x of y of s ds is equal to 0. So we get only the upper limit part, that is y of x alone. So we get, this implies y double dash of x plus y of x is equal to x. This is the twice differentiable function of the given integral equation. Now we will go by option by option. Option A, y of x is equal to 1 by 6 integral 0 to x s cube sine of x minus s into ds. Here y dash of x is equal to 1 by 6 outside, and when you differentiate here with respect to x, we get integral 0 to x cos of x minus s into this s cube as it is, and then ds. And when you take the upper limit, we have differentiation of x is 1, and you have to substitute x wherever s is present. So sine of x minus x will give you sine 0. Sine 0 is 0, and the lower is also 0. So we get y dash of x is equal to 1 by 6 integral 0 to x s cube cos of x minus s into ds. Now again take the differentiation. Y double dash of x is equal to 1 by 6. When you take the differentiation of this part, you will find integral 0 to x s cube as it is. Now taking differentiation, we get minus sine of x minus s into ds. And again, when you substitute the upper part, it will be plus 1 by 6. Here, the upper limit is x. When you differentiate upper limit, you get 1. And we have to substitute wherever s is present, we have to substitute it as x. So we get x cube into cos of x minus x. Cos of x minus x is, cos 0 is 1. So we get y double dash of x is equal to minus 1 by 6 into integral 0 to x s cube into sine of x minus s into ds. This is what your y of x is. So we get minus y of x plus x cube by 6. But this is not equal to the required thing. We need to get this one. We are getting a different one. So this option is false. The first option is false. Next, y of x is equal to 1 by 6 integral 0 to x s cube into cos of x minus s into ds. You can guess this option also. This is going to be wrong because it is as similar as the first option. S cube into cos of x minus s into ds. Y dash of x is equal to 1 by 6 integral 0 to x s cube into minus, take it outside. Okay, you'll have here cos of this is minus sine of x minus s, sine of x minus s into ds. When you apply the upper, you will find plus 1 by 6 here. This one I am taking it here also. 1 by 6 into, when you differentiate the upper limit, it is 1, and when you have to substitute wherever s is present, you have to substitute by x, right? So this is x cube into cos of x minus x here. This is equal to 1 minus 1 by 6 integral 0 to x s cube into sine of x minus s into dx, and then cos of 0 is 1, we get x cube by 6 here, x cube by 6, and this is y dash of x. Now take the, again differentiate, y double dash of x is equal to minus 1 by 6 0 to x, this is s cube into cos of x minus s into ds. And here sine of x minus x will give you 0, right? So it is not necessary, right? You will find 0 here, plus 0, and the lower limit is again 0. When you take the differentiation of a constant, you will find it 0. So again it is 0. The lower limit part is also 0, upper limit part is also 0, and you have to differentiate this one. So this differentiation is x squared divided by 2. So we get y double dash of x is equal to, this part is actually here y of x. So we get minus y of x plus x squared. So it is y double dash of x plus y of x is equal to x squared. But what we need is equal to x. We need x here, right side. Y double dash of x plus y of x is equal to x is the required thing, but we are getting a different one. We are getting x squared in the RHS, so this is also false. Option 3, y of x is equal to integral 0 to x, x into sine of x, s into sine of x minus s into ds. And the third option is y of x is equal to integral 0 to x s into sine of x minus s into ds. Yes. Now here y dash of x is equal to integral 0 to x, s as it is, differentiation of sine is cos of x minus s into ds, and applying the upper limit, we get sine of x minus x will become 0, so everything will become 0, and y double dash of x is equal to integral 0 to x, differentiation of cos will give you minus sine, so we have minus s into sine of x minus s into ds, and applying the upper limit, we have x into cos of x minus x, which is equal to minus integral 0 to x, s into sine of x minus s into ds, plus x into cos 0 is 1. So this is y double dash of x. So y double dash of x is equal to, and this part is y of x, right? So this is y of x, so minus y of x plus x. So we get y double dash of x plus y of x is equal to x. This is what the required twice differentiated function is, this one. So we get the third option is true. This option is true. As it is part B, only one answer is true. You can also verify the fourth option. This will be wrong for sure. Only third option is the correct answer. Next question. This is an easy question. Let u is equal to set of all continuous functions, twice continuous functions in the interval 0, 1, satisfying for some lambda not equal to 0 and a not equal to 0. The u of x is given by plus lambda by 2 integral 0 to 1 modulus of x minus s into u of s into ds is equal to ax plus b. Again the same Leibnitz rule only. We have to take the differentiation, first derivative and second derivative. That is what given in the option. Now we will go with first derivative. Before moving on to the derivative, we have to eliminate this modulus, right? So usually we eliminate modulus inside the integral equation, integrals by the constant which is having. Now here it is x minus s. Modulus of x minus s is equal to x minus s if x is greater than or equal to s, and minus of x minus s if x is strictly less than s. This is what we write. Okay, I have taken x as the variable and s to be the constant. If I have so, then I'll be writing of this type. Now here it is moving from 0 to 1. So from 0 to 1, I have to, this is a limit of s. So the s has the limit from 0 to 1. So I have to split it in such a way that it should involve x. So I'm going to replace the 0 to 1 by 0 to x and x to 1. So I should have 0 to x and x to 1. Here when you see s is moving, s is less than or equal to x. So here s will be lying in between this and s is lying in between this, right? So when I have this one, x is greater than or equal to s, x is greater than or equal to s, so I'll have x is greater than or equal to x here. If x is greater or equal to x, the corresponding function would be x minus s. And here for this one, when x is less than s, I'll have minus of x minus s. So I'm going to split the integral. It is u of x plus lambda by 2 integral 0 to 1. Here modulus of x minus s. So integral 0 to 1 must be replaced by integral 0 to x. So integral 0 to x, I'm going to use this one, x minus s into u of s into ds. And then this part plus lambda by 2 integral x to 1. This is going to be minus of x minus s into u of s into ds. This is equal to ax plus b. Now take the differentiation. U dash of x plus lambda by 2 integral 0 to x. When you take the differentiation inside the integral, you will find the differentiation of x minus s is 1. So you will find only u of s ds. And the differentiation of the upper will give you 1 upper limit, and also you have to substitute wherever s is there, you have to substitute by x, right? So when you substitute here, what will happen? Plus the differentiation of this x is 1, right? And when you substitute instead of s, you have to substitute x. So when you substitute, it is becoming 0 into u of s. This is what we will have. So the upper part is actually giving you 0 and the lower part is eventually 0. It is a constant. So when you differentiate a constant, you will have 0. So this is going to be 0. And then for this part, we will take the negative outside, minus lambda by 2. And then this x to 1. Differentiation of this part, x minus s into u of s ds. So that will give you u of s into ds. And the upper limit is 1 here. So upper limit will become 0. As you differentiate 1, it will become 0. And the lower limit is actually x here. And when you differentiate x, it will be 1. And you have to apply wherever this term is having, yes, you have to apply x, right? So x minus x will give you 0. So this is equal to u dash of x plus lambda by 2 integral 0 to x u of s ds minus lambda by 2 integral x to 1 u of s into ds, which is equal to a. Here right side, we have a, differentiation of ax plus b. Now we are going to combine these two. It is u dash of x plus lambda by 2 outside. So you have integral 0 to x u of s ds minus integral x to 1 u of s ds is equal to a. Now look at the option. What is given in the option? Du by dx is equal to, they have combined lambda by 2 is taken outside and they have combined the integral for the limit 0 to 1. They have used x minus s and modulus of x minus s. Now we are going to use the same thing, u dash of x plus lambda by 2 integral 0 to x. Now this is x minus s divided by x minus s, positive part you get, and then this u of s as it is into ds minus, here I'm going to have plus here, integral 0, this is x to 1, integral x to 1 x minus s divided by minus of x minus s into u of s ds is equal to a. So this is equal to, when you cancel these terms, you get the previous step. So this is u dash of x plus lambda by 2. This is integral 0 to x, this one. So I'm going to replace integral 0 to x, x minus s divided by modulus of x minus s into u of s into ds plus integral x to 1 x minus s divided by modulus of x minus s into u of s ds is equal to a. Good. Now this is equal to u dash of x plus lambda by 2 integral 0 to x x minus s divided by modulus of x minus s into u of s into ds is equal to a. So we get this answer is true and this is false. So we get positive for the lambda, a small change in the option. Next, we have to take the second derivative, u double dash. We shall use this one, mark it as 1 or star. We will use this one, this step to find the u double dash. What is given in the star? U dash of x plus lambda by 2 integral 0 to x u of s into ds minus lambda by 2 integral x to 1 u of s into ds is equal to a. So u double dash of x plus lambda by 2. Here this integral will become 0 because it is independent of x. And when you apply the upper limit, you get u of x. And then here minus lambda by 2. Here the limit, partial derivative of this will be 0 and upper limit is actually 0 because upper is having constant. So lower will be the variable. So here we have the differentiation of x will give you 1 and a negative. So actually what is happening here is you will take the differentiation of this part, right? So when you take the differentiation of this one, integral x to 1 dou by dou x of u of s into ds, and then you will go with the upper Upper limit is a constant, so the thing will become 0, differentiation of the upper limit. And the lower limit differentiation, this will have a negative. Whenever lower limit comes, we will have a negative of the lower limit differentiation, which is equal to 1. The differentiation of x is 1, and u of x, close the bracket, which is equal to 0 here. When you take the differentiation of a constant, which is equal to 0. So u double dash of x plus lambda by 2 into u of x plus lambda by 2. This is going to be 0. This is going to be 0 because the term is independent of x. Only s is here. S will be considered as a constant in terms of partial derivatives. So this is already a 0, and then negative into negative, we have positive lambda by 2 into u of x is equal to 0. So u double dash of x plus lambda into u of x is equal to 0. So this is what u double dash of x, u double dash, that is d squared u by, this is d squared u by dx squared plus lambda u is equal to 0. Plus lambda u is equal to 0. So first option is true and the second one is false. Thank you.